Hi, my name is Rob Hindman. I'm a Senior Program Manager. Our title today is Highly Available, Always Scalable, Failover Clustering and S2D in Windows Server 2025. Our agenda today, we'll be talking about what is failover clustering features in Windows Server 2025, improvements that are coming later this year, and features that we're working on for the next release. Our mission in failover clustering is to enable Windows Server and Azure local customers to achieve high availability for their applications, services, and components in private, hybrid, and adaptive clouds. Almost any environment where you're running stateful services, you can run failover clustering to achieve that. We share operating system components very broadly over a number of our operating systems and a number of our products. In failover clustering, we're a continuation of the story of hosting services. Stateful services that you can host on a standalone server or two machine scenarios. Failover clustering can help you to host those services in a highly available fashion. Our most popular workloads are Hyper-V VMs, the scale-out file server, SQL Server availability groups, SQL Server failover cluster instances, and just what we call gen service, any generic stateful service, file servers for general use, and a large number of third-party services like SAP's ASCS and NetWeaver. Also, you can see at the bottom of the slide the various topologies that we support. Most of our customers run a failover cluster in a single rack attached to a SAN or S2D. Many of our customers want to run failover clustering in a two-rack scenario, and we'll talk about that later in this presentation. Another topology is two-site stretch cluster, and then also we have multi-cluster scenarios. This is our journey to improve all these scenarios, and let me show you where we're at. But just as an overview, let's talk about the 7 elements of a failover cluster. For failover clustering, we're always going to have management, workload, identity, compute, storage, networking, and quorum, right? We always have these 7 elements. And in these 7 pieces, right, within them, there's always going to be choices, right, that customers have. So for example, networking, we work great with either IPv4 or IPv6. We work great with static IP addresses or dynamically assigned IP addresses. In terms of management, for example, right, you can manage a failover cluster from PowerShell or from ClueAdmin, also known as the Failover Cluster Manager. You can manage it from the Windows Admin Center or from SCVMM or from the Azure portal in the case of Azure Local. The workloads I've already talked about a little bit, but we support a huge number of workloads. SQL Server FCI, SQL Server availability groups, the scale-out file server, Hyper-V VMs, and other infrastructure workloads, also like software-defined networking. In terms of identity, we support Active Directory, and also we support Workgroup clusters, which we'll go over in a moment. So as you can see, there's a variety of ways that you can put together a failover cluster using these components. And this flexibility really gives our customers a great deal of options. So there's a lot of different ways that you can put a cluster together to achieve high availability for your stateful workload. I want to talk about a few features that landed in Windows Server 2025. So the first feature that I want to talk about is Workgroup Cluster Live Migration. We've supported Workgroup clusters since Windows Server 2016, but until the Windows Server 2025 release, we weren't able to support VM live migration on a failover cluster. But now we can, because you no longer need Active Directory as a strict requirement to achieve VM live migration. And so this is going to be very, very helpful in small deployments, maybe retail, maybe some factories where you want to minimize the number of servers, but you still want to achieve high availability, and you don't want to use an Active Directory controller. A number of our customers are very interested in this scenario. And so finally, we can support VM live migration on a failover cluster. So instead of Kerberos tokens, this technique will use PKUDU tokens, which are generated by the cluster itself. Another feature in Windows Server 2025 is GPU-P VM live migration. When a VM is being migrated between hosts in a failover cluster, we're now able to completely drain and then rehydrate the memory in the GPU that the servers are using. In this case, I've got two host machines and the GPU is partitioned in two pieces. That means that each VM can use a GPU partition, and it means that when I fail over VM 1 from host 1 to host 2, it'll successfully drain the GPU memory from host 1 and then rehydrate it on host 2 successfully. This is fantastic, especially for machine learning and also for inference workloads. This works great. And we're also, I should mention, we're continuing to support an increasing number of GPU cards for this feature. So really, really happy about that. The next feature I want to talk about that's new in Windows Server 2025 is ExcelNet for highly available VMs. When you're using Azure Arc for server on your cluster nodes, then you can use this feature and you can basically achieve direct connection between a physical NIC and the vNIC on your VMs. So this gives you acceleration because it bypasses the virtual switch. So it's one less layer. This is exactly the same technology that's used in Azure. A lot of customers will, really benefit from the improved speed using this feature. So this is really, really great. Next, I'd like to talk about the features that we're bringing into Windows Server 2025 later this year. The first feature that we're going to bring into Windows Server 2025 is S2D storage plus SAN coexistence. We're going to enable customers who are running their failover clusters using storage spaces direct or S2D storage in a single rack to connect their SANs, be it an iSCSI SAN or fiber channel SAN, to their failover cluster. So we have a lot of customers who are asking for this, who are asking for support for S2D plus SAN coexistence, because a lot of our customers have SAN storage and they want to use it, right? They want to use it together with S2D. So later this year, we'll document this as a supported scenario for Windows Server 2025. So you can connect a fiber channel or iSCSI SAN directly to your failover cluster that's running S2D. And the CSV volumes, the cluster shared volumes, can coexist peacefully. But the disks on the SAN are completely different than the disks that are in the S2D storage pool. So the disks do not commingle at all. So at any time, technically, you can disconnect your SAN and move it to another server if you wanted to. Another interesting thing here is currently you have to format the SAN LUN volumes as NTFS, but the S2D volume should be formatted as REFS. So I'm very excited about supporting this scenario. This should be really, really good. Another feature that's coming later in 2025, we will support S2D Stretch Clustering on Windows Server 2025. So initially, we're going to have the same requirements that Azure Stack HCI 2022 H2 has. Initially, we'll ask customers to first evaluate this topology called the Campus Cluster, which we'll discuss next. And then, if the Campus Cluster isn't a good fit, then we'll ask them to look at the Stretch Cluster. We have several customers asking for this, and we'll support it and document this as supported on Windows Server 2025. So I see this scenario evolving over time on Server 2025. So next, let's talk about the S2D Campus Cluster, which has a rack-sensitive four-way mirror. I'm very, very excited about this scenario. Right? Many customers have asked us for this, which is a sort of a simplified version of the Stretch Cluster because it doesn't use storage replica, which is nice. It doesn't use storage replica. It doesn't require a layer 3 switch. So the idea here is that when you configure the rack fault domains in a failover cluster, then you can create either 2-copy or 4-copy volumes, and you can get better resiliency. In the case of a 4-copy volume on a 4-node campus cluster, we actually achieve a new level of resiliency, which we call rack plus node, and which means that you can technically lose an entire rack and you can lose a node in the other rack and still remain running with a full copy of your data. So very, very happy about this feature. It should work, really, really well. And basically the idea here is that customers will have a choice between 2-copy volumes or 4-copy volumes. And so, for precious data, you can put it on your 4-copy volume and you'll have lower capacity on a 4-copy volume, you get better protection. So precious data, precious VMs can run on that rack-sensitive 4-way mirror. Now, with the campus cluster, right, we have specific guidance for this. We recommend that storage should be flat. In other words, the storage should be all capacity drives. Those drives should be SSDs or NVMe disks. Customers shouldn't be using HDDs. We recommend 1 millisecond of latency between the racks, so 1 millisecond or less latency between the racks. As I said, customers can create either a 2-copy or a 4-copy volume. I strongly recommend RDMA network cards in these systems, although it's not strictly needed. The campus cluster will work just fine on non-RDMA NICs, but the problem with non-RDMA is that it'll use more CPU. Your throughput is going to be lower with non-RDMA NIC cards. This topology doesn't use storage replica and doesn't require a layer 3 switch. And initially, we won't have a way to convert volumes. So you'll have to copy things off. So upgrades from existing campus clusters will be harder. I should note this feature is also known as a rack-aware cluster in Azure Local. So check with the Azure Local team for specific guidance. In the future, we're working on a very interesting feature called cluster native updating. This is something we're working on for the next version of Windows Server. I'm very excited about this. So patching a failover cluster while the workload is running, either with a monthly patch or with a feature update or an OS upgrade, it's a very tough problem. And in order to tackle this problem, we've decided to rewrite the orchestration process and embed the orchestration process directly into the cluster. We're very excited to do that. So this is just a little teaser. We'll have a really good demo for you next year. With that being said, I just want to say thank you very much for attending this presentation. Really appreciate it. And yeah, looking forward to talking to you again soon.